Pre-calc lens. We look at this. We look at the highest degree, and we see that we have an x squared. So we say, okay, 5x squared over 1x squared, 5 over 1, y equals 5. Horizontal asymptote, also known as end behavior asymptote. We don't know what's happening in between there, but we know at infinities we are going to 5 on both sides. We look at the highest degree is x squared, so we take 0 x squared over 5x squared. We get 0 over 5, which is 0. 3x squared. So over 3x squared over 3, 0 divided by 3 is in fact 0. We don't know what's happening in the middle, but we know at the infinities we are going to 0. We look at the highest degree, it's x cubed. We look at 1x cubed over 0, x cubed, 1 over 0, undefined. Horizontal asymptote doesn't exist. We know the top is 1 bigger. In this case, we actually do know there's some kind of slant asymptote. So as we go off to positive infinity, we're positive. As we go off to negative infinity, we'll be negative. The thing about this is you had to trust me on this in pre-calc, right? That this actually worked. There's no sound reasoning for it. So now we're going to take the calculus approach, and we're going to actually look at what happens. The limits at infinity literally means the limits at the infinities. So the limit as x goes to infinity of 5x squared plus x plus 1 over x squared plus 2x plus 3. If we plug in direct sub, we get infinity over infinity, which is indeterminate. So I need to manipulate. I manipulate by dividing by the highest degree of the denominator, x squared. I'm going to write the step out the first time. You don't have to write it out after that. 5x squared divided by x squared plus x divided by x squared plus 1 divided by x squared over x squared plus 2x over x squared plus 3 over x squared. Now, I'm going to simplify that. I'm keeping my limit because I haven't applied it yet. And I get 5x squared over x squared, which is 5. X divided by x squared is 1 over x. And 1 over x squared doesn't simplify. X squared over x squared is 1. 2x over x squared is 2 over x. And 3 over x squared stays the same. Now I'm going to apply my limit. I'm going to plug the limit in, and that's infinity, and I get 5 plus 1 over infinity plus 1 over infinity squared, all over 1 plus 2 over infinity plus 3 over infinity squared. My limit was taken. I dropped the limit out. I've applied it. The next few problems, a couple of these steps are going to be not as necessary. You can do them, but you don't have to. So I get 1 over infinity, 5 is 5. 1 over infinity is 0. 1 over infinity squared is 0. 1 divided by a very large number is 0. 1 plus 0 plus 0 equals 5. So our pre-calc lens, we took the highest degrees and divided, but we didn't really have a reason why. The calculus approach shows us what happens when we take a limit at infinity. It's indeterminate. We manipulate by dividing by the highest degree of the denominator. It turns into something that lets us evaluate it, which gives us a number 5 plus zeros over 1 plus 0, which equals 5. Okay? A lot faster. Limit as x goes to infinity of 5x plus 1 over 3x squared plus 2x plus 1. We know it goes to 0 already. Let's take the limit as x goes to infinity, and let's divide by the highest degree, which is x squared. 5x divided by x squared is 5 over x. 1 divided by x squared is 1 over x squared. 3 divided by x squared is 3. 2 divided by x squared is 2 over x. 1 divided by x squared is 1 over x squared. So I just took that step and I did it in my head. I get to here. I'm going to apply the limit. I'm not going to show the infinity this time. I'm going to do that in my head as well. When I apply the limit, I no longer write it. 5 divided by infinity. 5 divided by a very large number, 0. 1 divided by a very large number squared, 0. 3, the limit at infinity of 3 is 3. 2 divided by infinity, 0. 1 divided by infinity squared, 0. 0 divided by 3 is 0. Now, this is end behavior, and so we're going to have to look at the limit as x goes to positive infinity first. And it's going to be of x cubed plus x squared plus 2x plus 7 over x squared plus 5. Highest degree of the denominator is x squared. Limit of the denominator, x squared. X cubed divided by x squared is x. X squared divided by x squared, 2x divided by x squared, 2 over x, 7 over x squared, over x squared divided by x squared, and 5 over x squared. Let's go to infinity, and I get infinity plus 1 plus 0 plus 0 over 1 plus 0. What's infinity plus 1? It's a bigger infinity. And when we divide by 1, it's still infinity, right? This guy goes to positive infinity, as we suspected with our asymptote. Now, the limit as x goes to negative infinity still would be this guy, so I'm just going to write it down. Go to negative infinity, I'll get negative infinity. Plus 1 plus 0 plus 0 over 1 plus 0. Negative infinity divided by 1 is negative infinity. Negative infinity and positive infinity go different directions in these cases. Now, that's not always the case. If it was x squared, a negative infinity squared would be a positive infinity. And they'd both go up. Okay? Now, these guys will both go to 0. Positive and negative. These guys will both go to a number, positive and negative infinity. But the ones that don't go to a number could possibly go off in different directions depending on positive or negative infinity. We look at this, we know the answer, negative 2/3 pre-calc lens. Calc lens, limit, x goes to infinity, divide by x squared, negative 2, plus 3 over x squared, over 3, plus 1 over x squared. Apply the limit. Don't write the limit anymore. Negative 2 plus 0 over 3 plus 0, negative 2/3. If this is a 4-point problem, 1 point for the limit sign, 1 point for the division, 1 point for showing your work, 1 point for the answer. By looking at this, it's going to 0 pre-calc lens. Calc lens, x goes to infinity, direct sub, infinity over infinity, indeterminate, manipulate, divide by the biggest denominator, x squared, negative 2 over x plus 3 over x squared, over 3 plus 1 over x squared. Apply the limit, 0 plus 0 over 3 plus 0, which equals 0. The limit as x goes to infinity of this function is 0. We look at example 3. We need to FOIL this out. Limit x goes to infinity. 2x cubed plus x over 2x cubed plus 3x squared minus 2x minus 3. Highest degree is x cubed. Limit, x goes to infinity. Divide, we get 2. Divide, you get 1 over x squared. 2, 3 over x, 2 over x squared, 3 over x cubed. Apply the limit, 2 plus 0 over 2 plus 0 plus 0, which equals 1. It's okay just to write this, but we could say the limit as we go to infinity of the function equals 1 as well. Limit x goes to infinity. Again, direct sub is infinity over infinity. So we need to divide by x squared. 2x, 5 over x squared, over 3, plus 1 over x squared. 2 times infinity, plus 0 over 3 plus 0, which is positive infinity. So in this case, we're just asked about positive infinity. We're going off to positive infinity. If I really wanted to, I could go and do it for negative infinity to see what happens on the left side. The limit as we go to negative infinity of 2x, 5 over x squared, 3 plus 1 over x squared. Plug in negative infinity times 2, it's still negative infinity, plus 0 over 3, plus 0, negative infinity divided by 3, negative infinity. So as we go to the left, we're going to negative infinity.